Hello, my people. Good morning, good afternoon, good evening. How are you doing? This is Tasien. I'm happy to be here again and welcome to Mathematics Analytics. In today's video, I'm going to solve this question under this yellow box, and it is marked as question number 19, but guess why is it question number 19? It is question number 19 of one examination that was done in Rwanda, and it was done last year, and it was a national examination for many options, and I hope solving this question will help students who are preparing for their national examination. So the options for that exam are these ones: MCB, MCE, MEG, PCMP, MPG, and PCM. So this is not only for students who are expecting to have their exam this year, but also for everyone who want to learn. So let's see this question. It was about conics. We have a polar form of a conic. The polar form is given here. R equal 10 over 2 minus 2 times cosine of theta. And we are asked to find the eccentricity of this conic, to identify the form of this conic, to locate the directrix of this conic, and finally to sketch this conic. And a student who will be able to do such kind of equation will secure his or her 15 marks in the national examination. So let's go to win. Let's study and go to win our exam. Yeah, so let's see how we can solve this kind of question. We are given a polar form of the conic, and the polar form that we have, let me take a pen, and I need a black pen. All right, we have given a polar form of a conic to be R equal to 10 over 3 minus 2 times cosine theta. Yeah, when we have a polar form of a conic like this, there is a number of things that we need to understand from this kind of conic. We need to understand first that when we have R equal to E times D over 1 minus E times cosine of theta, and or we have two cases, or if we have R equal to E times D over 1 plus cosine of theta, like this. What is E? What is D? In this case, in the first case, in this case, E is eccentricity. E is eccentricity, and D is a number that is going to give us the equation of the directrix. But then the directrix will have equation x equal to minus d, because we have let me take another color. When we have minus sign here, this minus sign, then the directrix will have this equation, and the eccentricity is always eccentricity. And in the second case here, in this case, E is always the eccentricity. This is eccentricity, And the directrix will have equation x equal to d. X equal to d, because we have a positive sign. Because we have this positive sign here, so we will have a positive sign here too. So we have x equal to d instead of being minus d. So we have x equal to d. So this will be the directrix. So what do we have to do in our question? If we come back to our question, in our question we have, instead of having, let me take another color, instead of having 1 here, instead of having 1, we have 3. So we have to transform this question so that we will have 1 at this level. So what do we have to do? What are we going to do is to transform this r equal to 10 over 3 minus 2 cosine theta, so that we will have 1 here. So how are we going to do this? We can rewrite r as 10 over 3 and times 1 minus 2 over 3, 10 times the cosine of theta, like this. And like this, we can also write it, in this way. R equal to now 10 over 3, and then over 1 minus 2 over 3 cosine theta. And this is the form that we have. And with this form, one can see that the eccentricity, if we compare this that we are getting with the general form up here, we can see that we can deduce that the eccentricity E is equal to 2 over 3. So I'm comparing these 2 over 3 and this eccentricity here. So you see, the eccentricity is equal to 2 over 3. And again, what do we have? Again, we have that E times D will be equal to 10 over 3. And why? Because I'm comparing this 10 over 3 and this here, E times D. So E times D is equal to 10 over 3. And then you can see that from here we have eccentricity equal to 2 over 3, and D is equal to 10 over 3 divided by E. And if we divide by E, it's dividing by 2 over 3. So what are we going to get? This will give us, let me go here, eccentricity equal to 2 over 3, and D will be equal to 10 over 3 times 3 over 2. So 3 and 3 are simplified, and we remain with E equal to 2 over 3, and D is equal to 10 over 2, and 10 over 2 equal to 5. Alright, so the first question is already answered. The eccentricity is 2 over 3. So in A, we are asked to calculate the eccentricity. So A, eccentricity is 2 over 3. And in B, we are asked to write down the equation of the directrix. So since we have D, then B, the directrix will have equation x equal to minus D, because in our polar form we have a minus sign here. So it will have equation minus D, x equal minus D, which means x equal to minus 5, because D is equal to 5 here. All right. Eccentricity is equal to 2 over 3, and the directrix has equation x equal to minus 5. And in E we are asked to identify the form of this ellipse. How do we identify the form of ellipse having the eccentricity? We need to know this. Let me take this one a little bit up. I need this hand. Yes, then go up. All right. So how do we see in C? We are asked to identify the conic. How do we identify it? We identify it based on the value of the eccentricity E. When the eccentricity is less than 1, the conic is an ellipse. And when the eccentricity is equal to 1, the conic is a parabola. And when the eccentricity is greater than 1, the conic is the hyperbola. All right. So in our question, we have calculated the eccentricity, and the eccentricity is equal to 2 over 3, and 2 over 3 is less than 1. Since 2 over 3 is less than 1, so then it indicates that our conic is an ellipse. So we have an ellipse. Our conic is an ellipse. So this was E. And in D, we are asked to sketch. Our conic. In D, sketch the conic. We are asked to sketch the conic. And how are we going to sketch the conic? All what we have, we need to know. We need to know at least the foci, and the foci is at the origin, because this is said to be a standard conic. And then we need to know the vertices. And how do we compute the vertices? To compute the vertices, we are in the polar form, of course. We have to know the vertices when our angle theta is equal to 0, and when our angle theta is equal to pi. So if theta is equal to 0, r will be equal to what? Then r will be equal to 10 over 3 minus 2 times the cosine of 0. And this will be equal to what? This will be equal to 10 over 2 minus cosine of 0 is equal to 1. This is not 2, this is 3. Yes, all right. Then over 3 minus cosine 2 times cosine of 0. Cosine of 0 is equal to 1. Then 2 times 1. And then minus 2. 3 minus 2 is equal to 1. Then we get 10. We have 10. So the first polar coordinate of the vertex is, the first vertex will be, we have a polar coordinate 10, 10, 0. And in a Cartesian coordinate, how do we change this is the polar coordinate, but how do we change this into Cartesian coordinate? Cartesian coordinates. How do we change this into Cartesian coordinates? Or what we have to do is to use this relation x equal to r times cosine of theta, and y should be equal to r times sine of theta. This is the formula that we use to transform polar coordinates into Cartesian coordinates. So having this polar coordinate 10, 0, we will have that x will be equal to r is equal to 10, and our angle is 0, then times the cosine of 0, and y will be equal to 10 times the sine of 0. So we will have cosine of 0 is equal to 1, so x is equal to 10, and y will be equal to sine of 0 is equal to 0. 10 times 0 is equal to 0. So we have 10, 0. So we get the point 10, 0 in Cartesian coordinates too. So the first vertex is vertex, then if then the first vertex, the first vertex one is it has coordinates 10, 0 in Cartesian coordinates, and in polar coordinates, of course. And we need also to compute the second vertex when theta is equal to pi. If theta is equal to pi, what are we going to have? We will have y. So this implies that x first in we will have r equal to 10 over 3 minus 2 times the cosine of pi. I'm just replacing theta by pi. So this will be equal to 10 over 3 minus 2 times the cosine of pi. And cosine of pi is minus 1. So minus 2 times minus 1, this will be equal to 2. So this is equal to 10 over 2. We get, oh, not 10 over 2, 10 over 5. 10 over 5, which is equal to 2. 10 over 5. 10 over 5, which is equal to 2. All right. So the polar coordinate of the second vertex is, polar coordinate, the polar coordinate will be r is equal to 2. This is 2, and pi 2 pi. So in Cartesian coordinates, what are we going to get? If we change this into Cartesian coordinates, what are we going to get? We are going to use again the same transformations. This one, we use the same formula, x equal r cosine theta and y equal r sine theta. And what are we going to get? We are going to get x equal to r is equal to 2, and then times cosine of pi, and y will be equal to 2 times sine of pi, and this will be x equal to cosine of pi is minus 1 equal minus 2, and y equal to 0. So the second vertex will be equal to, it will have coordinates minus 2 and 0 in Cartesian coordinates. We have the second vertex 2, we have coordinates minus 2 and 0 in Cartesian coordinates. Yes, so now let's sketch it. I'm not going to sketch it, but I'm going to show how the sketch will look like. I already have a sketch here, then I'm going to show it to you. The sketch has this form. It will look like this, and you can see that on this sketch we have the force at the origin. This is the x-axis in Cartesian coordinates, and this one is the y-axis in Cartesian coordinates, and this point here is at minus 2. Yes, minus 2 0, and this point here is 10 0, the second vertex. So the ellipse will look like this, and that was it. This is what we have been asked to do. We have the sketch, and we have the form. It's an ellipse, and we have the directrix to have equation x equal minus 5, and we have the eccentricity to be equal to 2/3. I hope you have learned a lot from this video. If you happen to get another polar form of a conic, I hope you will be able to identify each and element of that conic. You will be able to find the eccentricity, to say what kind of conic you have, and the directrix, and you can sketch it, of course. So keep in mind that when you have negative here, the directrix will have x minus d, and keep in mind that when you have positive sign here, then the directrix will have equation x equal to d. And the other thing that you have to keep in your mind is that to identify the conic, the form of the conic is that when the eccentricity is less than 1, we have an ellipse, and when the eccentricity is equal to 1, we have a parabola, and when the eccentricity is greater than 1, we have the hyperbola. Yes, if you like this video, don't forget to click like and share this video to your friends. Let them know that we are learning, and then tell them that they can come and join us. Yes, thank you for watching, and I hope to see you for next time. Next time I will be solving question number 20 of this exam. Hope to see you. See you soon. Bye.